December 1943. A German recovery crew stands around a wrecked American fighter, its wings torn, its fuselage riddled with holes. Engineers crawl over it, pulling panels, taking measurements, prying open access bays. One of them mutters, "Impossible, this shouldn't even work." Another shakes his head. Not a single part can be reproduced. And in that moment, Germany realized something devastating. They weren't fighting a plane. They were fighting an industrial miracle, one the United States was producing by the tens of thousands. When American pilots spoke about the P-47 Thunderbolt, they said it felt less like a fighter and more like a flying power plant. A 2,000 horsepower engine, 8.50 caliber Brownings, armor thick enough to stop rifle fire, a frame so rugged pilots joked it could fly through a brick wall. It was the heaviest single-engine fighter of the war, a brute. But when Germany recovered its first relatively intact P-47, they expected to learn its secrets. Instead, they found something they hated: American simplicity achieved through impossible complexity. Inside the Thunderbolt's fuselage, German engineers found wiring looms arranged in layer clusters, color-coded, bundled, and installed with precision Germany simply couldn't replicate at scale. The engine baffled them even more. The Pratt Whitney R-2800 wasn't just powerful, it was reliable, built with metallurgy Germany didn't have, machine tools they couldn't produce fast enough, and tolerances their factories couldn't maintain under Allied bombing. Every bolt, every gasket, every piece of tubing was standardized, stamped, uniform, replaceable. That was the key. Germany could craft masterpieces: the Me-262, the Bf-109, the Fw-190. But they couldn't build 15,000 of them identical. The United States could. To German eyes, the Thunderbolt wasn't a fighter. It was a symbol of a nation that could build 50,000 planes a year, and then simply decide, let's build more. American factories were operating on a scale the Axis never matched. Conveyor belts stretching for miles, specialized jigs, interchangeable tooling, and a workforce that included men too old to serve, women who had never worked in factories, and even high school students in summer programs. Every worker had one job, one tool, one motion, and they repeated it thousands of times a day. That's how you build 15,683 Thunderbolts. Not with genius, with manufacture repetition. By 1944, Thunderbolts were everywhere. High over France, escorting bombers. Low over Germany, smashing trains, convoys, tanks, and airfields. Roaring over Italy, cutting supply lines. Sweeping the Pacific. Sometimes flying back to base on one cylinder after absorbing punishment that should have killed them. And the Luftwaffe was drowning. Pilots reported entire squadrons of P-47s diving from the sun in perfect formation. Engines screaming. 8 guns firing, leaving nothing but burning wreckage behind. One German ace wrote, "They built more engines than we built fighters." He wasn't exaggerating. By 1944, the United States was producing so many R-2800 engines that replacing a damaged one was faster than repairing it. Germany couldn't match that. Not even close. It wasn't lack of intelligence. It wasn't lack of engineering talent. Germany had brilliant designers, Messerschmitt, Tank, Heinkel. But Germany lacked something far more important in total war: replaceability. American factories used interchangeable parts, so precise that a component from a Thunderbolt built in Indiana could fit perfectly into one built in New York. German factories couldn't do that. Not when metal alloys were changing weekly. Not when slave labor sabotaged parts from inside. Not when factories were bombed, power was unstable, and materials inconsistent. The P-47 wasn't superior because of one engine or one weapon. It was superior because it came from a nation that could build the same airplane thousands of times with machine-like consistency. That was the real weapon. Summer 1944. Bomb groups heading toward Germany looked to their right and to their left and saw an ocean of Thunderbolts escorting them. Rows, Stacks, waves, some still factory shiny, others covered in soot, patched with silver skin, sporting shark teeth or dice or playing card art. It didn't matter. They all flew the same. They all fired the same. They all performed the same. The Luftwaffe's veterans were nearly gone. Fuel reserves were collapsing. New pilots were arriving with less than 20 hours in the cockpit, and above them, Thunderbolts. So many Thunderbolts. From the factories of America came a truth Germany couldn't escape. You don't win a war with prototypes. You win with production. In the end, the P-47 Thunderbolt wasn't the fastest or the most elegant or the most advanced aircraft of the war, but it embodied something even more lethal. Industrial inevitability. Germany built fighters that pushed the limits of engineering. America built fighters that pushed the limits of industry. And when total war demands not 100 aircraft, but 10,000, only one strategy works. The nation that can build the same machine again and again, without slowing down, without running out of parts, and without losing precision, that nation wins the sky. And in World War II, the Thunderbolt proved it.